What's up? We're back, and I'm gonna do projectile motion today. Yay! We did vectors in the last video. It still relates to vectors, technically. I'll try to relate that for y'all. But yeah, yo, I'm lucky meant to be reading like Catcher the Rye or something like that. Oh, I'm procrastinating. Whatever. Who cares? Anyway, a projectile is thrown with initial velocity v. Oh, at an angle of theta. What is the time it takes for a projectile to reach the ground again? So here we have the projectile, and bam, bam, and bam. So the first thing in all projectile motion, just remember this. Just remember it, and you could probably prove it when you like learn a lot. But the time it takes to go from zero to the peak is the time it takes from the to go from the peak to zero. It's a symmetry. I want to emphasize symmetry because it is like one of the most goated techniques. Symmetry, geometry, and kinematics. That's the only way they can get you. There's no way physics like Olympiads can get you on like just pure calculation because like anyone can do that. But symmetry, the geometry, like that's what makes Jan Calda so difficult. It's just the symmetry, like the plane problem, like the famous plane problem with Jan Calda. Yeah, it's like very difficult because like you need to like know like the geometries and stuff like that. So yeah, nail that in. Symmetry. Now, so the time it takes to go up here, time to go. It's the same. So what is the time it takes to go up from here, 0 to here? So at the peak, VF equals 0. The velocity here at the peak is 0. And it starts with an initial velocity of v sine theta minus gt. That's the equation, by the way. The original equation is VF equals VO VO plus GT. If you remember that, and just to prove this one even more, if you take the integral of this problem of this equation, you'll just like you'll get the big boy, the delta x equals to VOT minus one half GT squared, or the delta x equals VOT plus one half AT squared. That's a go. So yeah, and I wanna I wanna look at this term here. So when I have this vector, right? Let's say this ball is getting thrown at some angle. I'm looking when I do this equation, it's it's not like the two components combined. I have one equation for the x component and one equation for the y component. They're separate. They're different components. You don't make one equation for for everything, for all dimensions. You just split up the axes. You split up the things. You split the x from the y. That's how we do it. There's like independence. And like, if you need to see this, like, you should watch Walter Liu. Like, genuinely, he has such a good like lecture on this. I saw like the demonstration. I'm like, wow, it actually works. That's so cool. Anyway, yeah, I'll relate this back to vector. So the total velocity vector is going to be this. This is going to be the two components, right? If I add this x component to this y component, it'll give me this total velocity component. Yeah, and I want to find just a y component, right? Because when I'm talking about when it will reach the ground again, it's always gonna talk about like the y component. How far it goes is gonna be x component. When it reaches the ground again, it's gonna be y component. It only relies on y component, right? I drop a ball. I think I talked about it last video. But if I drop a ball and I make a ball with initial velocity v, they'll actually land at with the same time. See, because it's independent of component. The only thing that changed with this one is the x component changed, but the x component does not affect the y component. Yeah. So if we just solve sine theta equals to the opposite vy over the hypotenuse vt. Wait, opposite hypotenuse vy equals vt sine theta. Yeah. All right, anyway, that's how we got this term. Just because like when I was learning physics, like I was like, really confused. Like, wait, where are people pulling the sine and the cosine for? Like where does this even come from? But like, yeah, I hope that like explain it to you. If of course, if you have any questions, like if you got any questions, like I'll take them in the comments. Yeah. So this is it. This is the time it takes to get to the peak. The peak, not the end. The peak. Okay. Yeah. So what do? We just solve for it. T equals V O sine 2 theta. No, not 2 theta. Think about range. Sine theta all over G So that's to get to the peak. And remember, the time it takes to the peak is the same as the time it takes from the peak to zero. So therefore, it's 2 VO sine theta over G. Nice. That's one way to do it. There's another way. I'm not really sure. You know what? If I mess this one up, I'm still posting the video. I do not care. Y equals to VOT minus 1 half GT squared. 0 equals to factor out the T. VO minus 1. Oh, shoot. Sorry. Remember all that vector stuff that I was talking about before? Like, I need the diagram back. No. I want my diagram, my vector velocity diagram. Where'd it go? Where is it? Oh, there we go. Yeah, we still need it here. 0 equals to VO sine theta t minus 1 half GT squared. Factor out the t. Okay, and just divide over the t. You should get 1 half GT equals VO sine theta. And from there, you can just solve from t. So t, I mean, multiply over the 2. Theta all over g equals t. Bam. That's another way to get the equation. So he just proved two ways. I think there's like a way to do it with like energy, but we haven't covered that in this class. Like, is this a class? Am I calling this a class? Yeah, I got classmates. I mean, not classmates. I got students. This is actually kind of crazy. Yeah. But anyway, like, yeah, those are two ways we can do it. But when we get to energy, I'm sure there'll be like a question like that. Energy is also like the most goated unit of all time. Oh my God, it is so good. You can derive like anything from energy. But that's like me geeking out. Anyway, yeah. What do YouTubers usually say at the end of their videos? Well, like subscribe. Nah, you don't gotta. I don't really care. Yeah, but anyway, yeah. Thanks for watching the video. If you got any question on the problem, I'll try to help you out. Honestly, I'm still trying to navigate my life anyway. But if I can, I'll try to like, you know what I'm saying? Like, I'll try to help you out. Yeah, thanks. Thank you.